Hello everyone, it's Rester Kill, back at it again. Here to help Gus, he's having even more problems with his homework. It's alright Gus, I'll help you out. So what's the problem today, Gus? We're doing question 30. So the problem is, what is the mass of nitrogen present in 250 milliliters of 0.125 m potassium nitrate solution? So I'm going to write that information down. So 250 milliliters. Typically it's probably specified as 2.00 milliliters, but that really matters. Correct my units, sorry. And 0.125 m potassium nitrate, because as you know, nitrate's NO3, potassium's K. Solution. And what we want is the mass of nitrogen within this solution. You got that, Gus? So where do we go from here, Gus? Well, first of all, what are units? We're given milliliters and molarity. And if you recall, Gus, what is molarity? That's right. Molarity is M equals moles over liters. Yeah. So if we go plugging, so if we want to get, let's say, moles, we can plug in our pre-existing numbers they were already given to us to find out the moles of KNO3 within the solution. So let's go and do that. So we have 0.125 m. I'm not gonna write that because I feel like it. And here's the thing, guys. You might be tempted to write 250 milliliters in the bottom. However, that would be milliliters. We typically need it in liters. So to convert 250 milliliters to liters, we divide 250 by 1,000. And this would give us, over 0.25 liters over mole. And now we're going to solve for mole. If you remember your basic algebra, Gus, which I'm sure you do because you're very smart, you multiply by units, multiply on both sides. We cancel out the 0.25 liters on bottom, we're just left in moles. And this multiplied by this will give us our moles. So I'll hold on, put my calculator right here, sorry. And this will give us, well, I don't really know what that, but it's kind of a little more down. Yeah, sorry. And this will give us, sorry everyone, I am such an awful teacher. And this gives us 0.03125 mole of KNO3. Now we're done, right? Gus, we found out the amount. No, Gus, this is just in moles. It wants actual mass. And mass is usually represented by grams or kilograms, etc. So we're going to have to convert this to grams. Or more specifically, we need to figure out the mass of the nitrate itself. Because it doesn't want the actual potassium nitrate. It just wants the nitrogen within the potassium nitrate. So what do we do now, Gus? Well, as you know, let's look at potassium nitrate. So, how many nitrogen is within one potassium nitrate molecule? Gus? Very good. There's a ratio of one nitrogen atom per potassium nitrate molecule. So in other words, there is 1 mole of N per 1 mole of potassium nitrate. You see how this works, Gus? Because there's 1 nitrogen atom, and that means per 1 mole of nitrogen, there's 1 mole of potassium nitrate. It's crazy, I know. So now we can convert our potassium nitrate, our moles of potassium nitrate, to moles of nitrogen. What? I know. These guys, it's crazy. So let's go ahead and plug that in. So 0.3125 mole of yeah? See how this works, guys? Now we cancel out our units. and we're left with the exact same thing basically. However, now it's a nitrogen. Yeah? And that's our amount of nitrogen in moles. However, as you remember, Gus, we still want to know how much mass within nitrogen. So, if you're aware of what a mole is just the AMU of an atom multiplied by 6.22 times 10, blah, 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 right? So a mole is basically just, let me write this right over here. I'm trying to think where I should write this. I think right here would be fine, the bend down. So per 14.01 grams is equivalent to 1 mole of nitrogen. Because nitrogen is just a measurement. Hello. Measurement of, what's we'll call it? Sorry, I got interrupted by someone like guys. I feel like a maniac. But anyway, 1 mole is just a measurement, like a dozen. So 1 mole of nitrogen is equivalent to 14.01 grams. Does that make sense, Gus? And well, we know how many. Oh, I forgot to write mole right here. Sorry. And we know how many moles of nitrogen we have within our solution. So we can go ahead and convert how many moles we have to grams. So let's go ahead and do that, Gus. 0.03125 mole. Yeah? And the units will cancel out. I better write that down. And this will give us our final answer, the big number. I'll go ahead and write it over here. This will equal 4.37812 grams of nitrogen within the KNO3 solution. Got that, Gus? That is the big answer. However, we pay attention to safe things. Originally, we were given 250.00 milliliters, and that is 5 safe things, right, Gus? And we were also given 0.125, which is 3 safe things, right, Gus? So if we were writing this down with safe things, it would be 0.438 grams of nitrogen. You got that, Gus? Good job. Woohoo!